Here we will demonstrate how to use the HKLviewer to inspect problematic data such as the data file 3rbx.mtz, which we have already loaded. Datasets available are listed here in the Details tab. And if we have Phenix installed, then on the Quick View tab here we have these two buttons, Xtriage and Xtricorder. So now let's try and run Xtricorder to analyze the datasets in more detail. And once it's done, HKLviewer will load a new file with new datasets produced by Xtricorder, where the most interesting datasets are the TNCS and the anisotropy correction terms. If we go back to the Quick View tab here, we have these new buttons here, and we can try and rotate around the TNCS vector to display the data, how it will look with the TNCS correction terms. So we can see there's very strong modulation here in the data, so every 3 layer the data is quite strong, and the 2 middle layers it's relatively weak. So if we were to compute e-values based on this data, we would get something looking like this. So we just press the e-values button here in the Quick View tab, and we can see for the e-values, even there's quite strong modulation here. So this data here would be no good unless we apply the TNCS correction terms. Now, correcting the data is all done internally by Phaser, but let's try and manually do the TNCS correction here. Let's first display the intensities, and we go to the Details tab and find the intensities, and then we right click here and make a new data set, and we type new array ._data equals array 1.data divided by array 2.data. So array 1 corresponds to the intensities here, and array 2 will associate with the TNCS correction terms, which we find here, and we give it a suitable name, the new array, and we call it I/TPS, and unless I've made a mistake, this should compute. So here we have data that are intensities with the TNCS correction terms applied, but we also want to normalize it so we can better compare it to the other normalized data. So we make a new data set again here and type array 1.normalize.data, and we call this E for e-values, E_I/TPS, and this should compute. So this should be e-values where we have applied the TNCS corrections. So if we have a look at the rotate around TNCS vector and try and rotate these e-values around, we can do that by going here and clicking on the uncorrected e-values and rotate them as well. You can see that there are strong ripples in the data corresponding to the TNCS correction. Now if we go to the corrected e-values and rotate those around, we can see that there are no ripples in the data. So that concludes that we actually apply the TNCS correction to the data, and this data would be suitable for using in a molecular replacement search. Now let's show how to inspect the twin law. So let's load the Phenix tutorial dataset called Porin, which has got some twinning. We go back to the Quick View tab here, show the amplitudes data, and then we run Phenix Xtriage. And Xtriage tells us that there are these possible twin operators here, and the one with the lowest R factor, which is the last one, is the one that we're interested in. and we can go here on the Details tab and find the Vector tab and see that this is actually that twin operator here. So we go back to Quick View again, and let's slice amplitudes perpendicular to that twin operator. And what we should pay attention to is that when we step through layers of reflections, then according to the color coding we should see central symmetry, and that appears to be the case, so that indicates that this data set is actually twinned. What we could also do is to bring up the table of reflections for the data set, and then right clicking one data point here, we find that the value here is 1008, and the twin related value we can find from a tooltip being 901. So that indicates that these are within the same order of magnitudes, these two values here, and yeah, confirms that it's twin related.